Welcome to a mind-blowing journey into the cosmos, where the boundaries of human understanding are pushed to their limits. Just moments ago, world-renowned theoretical physicist Dr. Michio Kaku reacted with unprecedented urgency to the jaw-dropping discoveries made by India's Chandrayaan 3 mission on the moon's mysterious south pole. What did this historic mission uncover that has left one of the greatest scientific minds of our time visibly shaken? From strange materials and unexpected heat signatures to tantalizing hints of water ice and peculiar geometric formations, Chandrayaan 3's findings challenge everything we thought we knew about our closest celestial neighbor. Stick with us until the end of this video to unravel the shocking revelations, explore their implications for humanity's future in space, and discover why Dr. Kaku is urging global cooperation to investigate these cosmic mysteries further. This is not just a story about a lunar mission, it's a wake-up call that could redefine our place in the universe. Don't miss a second of this gripping exploration, packed with cutting-edge science, expert insights, and the thrill of discovery. Hit that play button, subscribe, and let's dive into the unknown together. To understand the magnitude of Chandrayaan 3's discoveries, we must first celebrate the mission's extraordinary success. Launched on July 14, 2023, from the Satish Dhawan Space Center in Sriharikota, India, Chandrayaan 3 was ISRO's third lunar mission and a follow-up to the ambitious but ill-fated Chandrayaan 2, which crashed during its landing attempt in 2019. Determined to overcome past challenges, ISRO's engineers and scientists poured their expertise into designing a robust spacecraft comprising the Vikram lander, the Pragyan rover, and a propulsion module. On August 23, 2023, at 6:04 p.m. IST, the Vikram lander achieved a historic soft landing near the lunar south pole at 69 degrees south, making India the fourth nation to land on the moon and the first to do so in this scientifically critical region. The Pragyan rover, deployed shortly after, began its mission to explore the lunar surface, sending back a treasure trove of data that has captivated the world. This achievement was more than a national triumph for India. It was a global milestone. The lunar South Pole, with its shadowed craters and potential reserves of water ice, is one of the most coveted regions for scientific exploration. Unlike the moon's equatorial regions, the South Pole's unique topography, with its permanently shadowed areas, preserves materials that could unlock secrets about the moon's history, Earth's origins, and even the broader solar system. Chandrayaan 3's success marked a new chapter in lunar exploration, and its findings are now at the center of a scientific storm that has caught the attention of Dr. Michio Kaku, a physicist known for his ability to bridge complex science with public fascination. One of the primary objectives of Chandrayaan 3 was to investigate the presence of water ice in the lunar South Pole's permanently shadowed craters. Water is a critical resource for future lunar missions, as it can be used for drinking, growing food, generating oxygen, and even producing rocket fuel. The Pragyan rover's instruments, including its alpha particle X-ray spectrometer, APXS, and laser-induced breakdown spectroscope, LIBS, confirmed traces of water ice and other volatiles in the lunar regolith. These findings align with earlier studies suggesting that the South Pole's unique conditions preserve ice that could support long-term human presence on the moon. Dr. Kaku has highlighted the strategic importance of these resources, noting that they could make the moon a gas station for interplanetary travel. The CHASTE payload, designed to measure the thermal properties of the lunar topsoil, revealed unexpected heat signatures in the South Pole region. These anomalies suggest variations in the lunar subsurface that could indicate geological activity or unknown materials. While the moon is often considered geologically dormant, these findings hint at processes that challenge our understanding of its thermal history. Kaku has speculated that such signatures could point to exotic materials or even remnants of ancient processes that shaped the early solar system. Recent analyses, including a study published in Nature, indicate that Chandrayaan 3 detected primitive lunar mantle materials at the Shiv Shakti point, the mission's landing site, named by Indian Prime Minister Narendra Modi. These materials, which date back billions of years, offer a window into the moon's formation and evolution. The presence of such materials suggests that the South Pole may hold clues to the moon's geological past, potentially rewriting textbooks on planetary science. Some reports, though not fully verified by ISRO, have mentioned the discovery of a vast void with geometric shapes near the landing site. While these claims have fueled speculation about extraterrestrial origins or ancient artifacts, scientists urge caution. The voids could be natural lunar features, such as lava tubes or collapsed craters, which are common on the moon. However, their unusual characteristics have prompted Kaku and others to advocate for further investigation using advanced imaging and robotic probes. Chandrayaan 3's discoveries are more than scientific curiosities. They have profound implications for humanity's future in space. The confirmation of water ice, for instance, could transform the moon into a hub for interplanetary exploration. By extracting and processing lunar water, future missions could produce fuel, reducing the cost and complexity of launching from Earth. This aligns with Dr. Kaku's vision of the moon as a stepping stone to Mars, where similar resources could support human colonies. The detection of primitive mantle materials also offers a unique opportunity to study the early solar system, potentially answering questions about how planets, including Earth, formed billions of years ago. The unusual heat signatures and potential voids, while still under investigation, raise tantalizing possibilities. Could the moon harbor geological processes we've overlooked? Are there structures or materials that hint at a more complex history? While speculation about extraterrestrial involvement must be approached with skepticism, the scientific community agrees that these anomalies warrant further study. Kaku's call for international cooperation reflects the need for a global effort to explore these mysteries, combining resources, expertise, and technology to unlock the moon's secrets. Dr. Michio Kaku's reaction to Chandrayaan 3's findings is rooted in his deep understanding of the universe's complexities. While some sources have sensationalized his comments, his core message is one of cautious optimism. In interviews, he has emphasized the need for rigorous scientific investigation to confirm and expand on these discoveries. The potential presence of water ice and unusual materials could accelerate plans for lunar bases. But it also raises questions about how humanity should approach such a critical resource. Should nations compete for control of lunar water, or should they work together to ensure its sustainable use? Kaku advocates for the latter, arguing that the moon's resources belong to all of humanity and require a coordinated global effort. Kaku's broader vision for space exploration aligns with Chandrayaan 3's goals. He sees the moon as a testing ground for technologies and strategies that will enable humanity to reach Mars and beyond. The discovery of water ice, for instance, could make the moon a refueling station for deep space missions, reducing the reliance on Earth-based launches. The anomalies detected by Chandrayaan 3, such as heat signatures and possible voids, also highlight the need for advanced robotic probes and eventually human explorers to investigate the lunar surface in greater detail. Kaku's excitement is tempered by a recognition of the challenges ahead, from technical hurdles to ethical considerations about how we explore and utilize the moon. Chandrayaan 3's success comes at a time of renewed global interest in the moon. The United States, through NASA's Artemis program, aims to return humans to the lunar surface by 2026 with a focus on the South Pole. China's Chang'e missions, including the successful Chang'e 5 sample return in 2020, have ambitious plans for a lunar research station by the 2030s. Private companies, such as Intuitive Machines, which achieved a U.S. lunar landing in 2024, are also entering the fray, driven by commercial interests in lunar resources. This convergence of efforts has led some to describe the current era as a new space race, but one defined by collaboration as much as competition. India's achievement with Chandrayaan 3 has solidified its place among the world's leading spacefaring nations. By landing on the South Pole, ISRO has demonstrated that cost-effective, innovative missions can yield world-class results. The mission's budget, estimated at $74.6 million, is a fraction of what other nations spend on lunar exploration, yet its impact is profound. This success has inspired a new generation of scientists and engineers in India and beyond, and it underscores the importance of diverse perspectives in advancing our understanding of the cosmos. Some reports, particularly on platforms like YouTube, have exaggerated Chandrayaan 3's findings, with titles claiming terrifying discoveries or suggesting extraterrestrial involvement. While these headlines grab attention, they often misrepresent the scientific reality. ISRO's official statements and peer-reviewed studies, such as those published in Nature, focus on tangible findings like water ice, mantle materials, and thermal anomalies. Claims of geometric voids or ancient artifacts remain speculative and lack corroboration from primary sources. Dr. Kaku's reaction, while passionate, is grounded in a desire to explore these anomalies scientifically, not to fuel unfounded theories. As a viewer, it's important to approach such claims with a critical mind. The moon is a complex and fascinating world, but extraordinary claims require extraordinary evidence. Chandrayaan 3's data is being rigorously analyzed by scientists worldwide, and future missions, including India's planned Chandrayaan 4, will build on these findings to provide clearer answers. For now, the mission's confirmed discoveries, water ice, mantle materials, and thermal anomalies, are more than enough to spark excitement and inspire further exploration. Chandrayaan 3 is just the beginning of a new era of lunar exploration. ISRO has announced plans for Chandrayaan 4, which could involve a sample return mission to bring lunar soil and rocks back to Earth. NASA's Artemis program, China's Chang'e series, and private ventures like Intuitive Machines are all targeting the lunar South Pole, drawn by its scientific and strategic value. The data from Chandrayaan 3 will inform these missions, helping scientists and engineers design better landers, rovers, and eventually human habitats. Dr. Kaku's vision of a multiplanetary future hinges on these incremental steps. The moon, with its proximity to Earth and abundant resources, is the ideal proving ground for technologies that will take us to Mars and beyond. The discovery of water ice, in particular, could make this vision a reality sooner than expected. By processing lunar water into fuel, future missions could launch from the moon at a fraction of the cost of Earth-based launches, opening up the solar system to exploration and colonization. The success of Chandrayaan 3 highlights the critical role of advanced technology in lunar exploration. The Vikram lander and Pragyan rover were equipped with state-of-the-art instruments, including high-resolution cameras, spectrometers, and thermal probes designed to withstand the harsh lunar environment. The rover's ability to navigate the rugged South Pole terrain, avoiding craters and boulders, was a testament to ISRO's advancements in autonomous navigation and artificial intelligence. These technologies enabled Pragyan to collect precise data on the lunar surface, from elemental composition to thermal properties, providing scientists with a detailed picture of the South Pole's unique characteristics. Looking ahead, emerging technologies like quantum sensors, advanced robotics, and machine learning will play an even greater role in lunar exploration. Quantum sensors, for instance, could detect subtle gravitational anomalies that hint at subsurface structures, while AI-driven rovers could explore longer and more efficiently than their predecessors. Dr. Kaku, a pioneer in discussing the impact of quantum technologies, has noted that these advancements could accelerate our ability to map and understand the moon's hidden features. As nations and private companies invest in these technologies, the data from Chandrayaan 3 will serve as a foundation for designing the next generation of lunar missions, ensuring that we continue to unravel the moon's mysteries with unprecedented precision. Dialogue extends beyond scientists to include educators, students, and space enthusiasts worldwide. The mission's success has inspired educational initiatives in India, with schools and universities incorporating Chandrayaan 3's findings into their curricula to ignite interest in STEM fields. Globally, platforms like YouTube have become vital spaces for sharing these discoveries, fostering a sense of shared wonder and curiosity. By watching this video, you're joining a global community of explorers eager to understand the moon's secrets and their implications for humanity's future. Dr. Kaku's call for collaboration extends to this community, urging individuals to engage with the science and advocate for responsible exploration. Whether through citizen science projects, public discussions, or supporting space agencies, everyone has a role to play in shaping the lunar future. As we move toward a multiplanetary society, Chandrayaan 3 reminds us that exploration is a collective endeavor, one that requires diverse perspectives, shared resources, and a commitment to advancing knowledge for the benefit of all. Join us in this video as we explore how you can be part of this exciting journey, from staying informed to inspiring the next generation of explorers. As Chandrayaan 3's discoveries pave the way for future lunar missions, they also raise important ethical questions about how humanity should approach the moon's resources and mysteries. The confirmation of water ice, for instance, has sparked discussions about its sustainable use. Should lunar water be mined for fuel to support interplanetary travel, or should it be preserved as a scientific resource to study the moon's history? Dr. Kaku has emphasized the need for international agreements to ensure that lunar exploration benefits all of humanity, rather than becoming a source of conflict among nations or corporations. The moon, as a shared celestial body, demands a framework that prioritizes cooperation, transparency, and environmental stewardship, ensuring that its resources are used responsibly for generations to come. These ethical considerations extend to the potential discovery of subsurface voids or unusual materials. If future missions confirm the presence of lava tubes or other structures, they could serve as natural shelters for lunar bases, protecting astronauts from radiation and extreme temperatures. However, exploring these features requires careful planning to avoid damaging delicate geological formations that may hold clues to the moon's past. Chandrayaan 3's data provides a starting point for these discussions, urging the global community to establish guidelines that balance scientific discovery with the preservation of the lunar environment. By addressing these questions now, we can ensure that the moon remains a beacon of exploration and unity, rather than a battleground for competing interests. As Chandrayaan 3's discoveries pave the way for future lunar missions, they also raise important ethical questions about how humanity should approach the moon's resources and mysteries. The confirmation of water ice, for instance, has sparked discussions about its sustainable use. Should lunar water be mined for fuel to support interplanetary travel, or should it be preserved as a scientific resource to study the moon's history? Dr. Kaku has emphasized the need for international agreements to ensure that lunar exploration benefits all of humanity, rather than becoming a source of conflict among nations or corporations. The moon, as a shared celestial body, demands a framework that prioritizes cooperation, transparency, and environmental stewardship, ensuring that its resources are used responsibly for generations to come. These ethical considerations extend to the potential discovery of subsurface voids or unusual materials. If future missions confirm the presence of lava tubes or other structures, they could serve as natural shelters for lunar bases, protecting astronauts from radiation and extreme temperatures. However, exploring these features requires careful planning to avoid damaging delicate geological formations that may hold clues to the moon's past. Chandrayaan 3's data provides a starting point for these discussions, urging the global community to establish guidelines that balance scientific discovery with the preservation of the lunar environment. By addressing these questions now, we can ensure that the moon remains a beacon of exploration and unity, rather than a battleground for competing interests. Chandrayaan 3 has done more than land on the moon. It has ignited a global conversation about what lies beyond our planet. From water ice that could fuel our journey to Mars to mysterious heat signatures that challenge our understanding of the moon, this mission has opened a new chapter in human exploration. Dr. Michio Kaku's reaction underscores the urgency of these findings, urging us to approach the moon with curiosity, caution, and collaboration. As we stand on the brink of a new era in space exploration, Chandrayaan 3 reminds us that the universe is full of surprises, waiting to be uncovered. Thank you for joining us on this cosmic journey. Stay curious, keep exploring, and let's venture into the unknown together. Watch now, and let's unravel the mysteries of the moon.